Just when you think the well can't get any deeper, the rock bottom falls out from beneath you, and you find there are new depths you can sink to. Which is kind of where you are now. Up to now, everything you have studied in chemistry has been what we call general chemistry. And it's all of chemistry in a basic introduction, and basically it's, here's the periodic table, can you read it? There is an entire different section of chemistry called organic chemistry, and it deals with all the reactions and all of the compounds that contain carbon. Carbon, like all elements in group 14, has 4 valence electrons. And because it has 4 valence electrons, it has the capability to actually form 4 covalent bonds. Being a nonmetal, any bond that it forms will be a nonmetal bond, so covalent. It can form covalent bonds with any nonmetal, such as it does here with hydrogen, or it could form it with itself, such as seen here when these 2 carbons bond together. And this could go on indefinitely. It can form a single bond with itself, it can form a double or even a triple bond, because carbon is one of the more versatile when it comes to its electron sharing. So because of this, carbon, or organic molecules, can form millions of compounds. In fact, most of the compounds nowadays are synthetic compounds or organic molecules in nature. We use them in clothes, such as polymer blends of fabrics. In pharmaceuticals, the aspirin you're taking is an organic compound. The plastics, such as PVC pipe that your water travels through, are all organic compounds. Foods, such as sweeteners and sugars, organic molecules are all around you. Even your body is made up of organic compounds. The fatty acids in your lipid bilayer of your cells are organic. Your DNA is an organic molecule, all of which contain carbon. Molecules that maintain and reproduce life are called biomolecules. So while all biomolecules are organic, not all organic molecules are biomolecules. So as you can see, carbon can form long carbon chains. When you have several short chains, also known as monomers, that come together, they will form a polymer, which is a long chain of molecules made from monomers. Polymers are what you see every day. So the PVC pipe that your water travels in is a polymer. The way that a polymer is made is that a monomer is reacted with a free radical, which is just anything that has an unpaired electron. That unpaired electron will attract one of the hydrogens off of the monomer and destroy the double bond of the carbons. So now you have a carbon here that does not satisfy the octet rule. It has this extra electron laying around on its side. The free radical goes off to go away. But that carbon is still not satisfied the octet rule. So what it does is it acts as a free radical to another monomer. And it attracts the hydrogen and breaks the double bond of this monomer. So now this carbon has an unpaired electron. And the process continues forever and ever and ever until you run out of free radicals, until 2 free radicals react with one another. This type of adding monomers together to make your polymer results in what's called an addition polymer, when monomers simply add together to make the polymer. For example, see your table in your notes of some of the common ethylene-based polymers. When a polymer is made of only one monomer, so for example, when you have polyethylene, which is made of all ethylene molecules, or all ethylene monomers, it is called a homopolymer because it's all the same. When you have a polymer that's made of 2 or more monomers, like, for example, styrene and butadiene, which is another monomer, get together, they form styrene-butadiene rubber, which is known as synthetic rubber, and it's much stronger than just plain old rubber. But not all polymers are synthetic. Some polymers are actually made naturally in the body. For example, DNA is a natural polymer. It is a long carbon chain involving phosphorus, nitrogen, oxygen, and hydrogen, but they're all held together by carbon. Proteins in your body are made up of monomers that come together to perform a particular task. Whether that task is to hold on to oxygen or to allow transportation into and out of the cell. Even the cell wall is made of a phospholipid, which is a type of polymer. The strength of a polymer can be increased by allowing it to cross-link. Since polymers form long chains, if you were to chain a chain to another chain, you would form a cross-link. So for example, polyisoprene forms polyisoprene, which is a polymer. If you put sulfur in it in a process called vulcanization, you allow it to form these sulfur bonds in between each chain of the polyisoprene. And this will cause it to be a much stronger substance. The rubber in your tires undergoes vulcanization so that it increases in strength.